algebra. First, secondary first term. The lesson 5, the sign of the function. Sign of the function. First, sign of the constant function. Sign of the constant function f, where f of x equals c, c not equals 0, is the same as the sign of c. Again, sign of the constant function f, where f of x equals c is a constant number, c not equal 0, is the same as the sign of c. What's the meaning of sign of constant function? What is the constant function? The constant function is the function which is the only number. For example, f of x equals 5. This function is a constant function. There is no x, there is no variable, only constant number. For example, f of x equals -2. It's called constant function because there is no variable in the function. So the first, to find the sign of the constant function, we will find the sign of the constant. For example, f of x equals 5, its sign is positive, so the function is positive. F of x equals -2, its sign is negative, so the function, its sign also will be negative. So the constant function is represented by a straight line parallel to x-axis, as we see in this representation. It represented by a straight line parallel to what? Parallel to x-axis, as you see. So if the line is above the x-axis, that means that c greater than 0, c, which is the constant value, greater than 0. So the function is positive for every x belongs to R. X which is belongs to the part which is more than or above the x-axis. In the second example, the line or the representation is below the x-axis. That means that c is smaller than 0. The value of c is smaller than 0. It's a negative number. So the function is negative for every x belongs to R. For example, determine the sign of each of the following functions. F of x equals 5, as we said in the above example, f of x equals 5. So, since the function is greater than 0, therefore the sign of the function is positive for every x belongs to R. Another example, if f of x equals -7, since f of x is smaller than 0, as we see it's a negative value, therefore the sign of the function is negative for every x belongs to R. So if the number is positive, so the function is positive. If the number is negative, so the function is negative. Second, the sign of the linear function. To find the sign of the linear function, for example, the linear function is f of x equals bx plus c. F of x equals bx plus c, where b not equals 0, x will be equal -c over b, where f of x equals 0. If we put the value of f of x 0, it will be bx plus c equals 0. So we can find the value of x, which is -c over b. Then the rule is, if -c over b in the first figure or in the second figure, so we will represent this part, which is number line. If the value of y is 0, so the answer is -c over b. before 0, the sign is opposite to the sign of the coefficient of x. After 0, it will have the same sign of the coefficient. يبقى before opposite, after same. Before will be opposite, after will be the same. For example, determine the sign of the function f where f of x equals x minus 2 and represent it graphically. The solution: we represented the function x minus 2. So this is the representation of the function as we see. To determine the sign of function, f of x equals 0. When f of x equals 0, when x equals what? When x equals 2. So f of x equals 0 when x equals what? When x equals 2. If x equals 0, then f of x equals what? Equals negative 2. So the first order pair is 2, 0. The second order pair is 0, 2. 2, 0, 0, 2. So we can represent the function. From the graph, we get the function is positive when x greater than 0. For every part greater than 2, the function is positive. And for when x equals 2, the function is 0. And the function is negative when x is smaller than 2. So the function is positive when x greater than 2. The function is negative when x is smaller than 2. And the function is 0 when x equals what? When x equals 2. So the function is positive when x greater than 2. The function is negative when x smaller than 2. And the function is 0 when x equals 2. Third, sign of the quadratic function. The quadratic function is f of x equals ax power 2 plus bx plus c. That's the quadratic function. So the quadratic function is ax power 2 plus bx plus c. We find first the discriminant of the equation. First, we have to find the discriminant of the equation. We put f of x 0. We put instead of f of x, we put it 0. And we find the discriminant. First, if the discriminant b power 2 minus 4ac greater than 0, then there are two real roots L and M. And that's the representation. So the curve will intersect the x-axis at L and M, whatever it's opened upward or opened downward. As we see, the representation is, we can see the representation step by step. What is this? It's the rule for the sign of the function for the quadratic equation or the quadratic function. So the number line, this number line, if y equals 0, f of x equals 0, so the answer is M and L. So between L and M, it will be opposite to the coefficient of x power 2. Before M, it will be as the coefficient of x power 2. After L, it will be as the coefficient of x power 2. So that's M, L, opposite, between, as. Opposite, as. As what? The sign of the coefficient of x power 2, or opposite to the sign of the coefficient of x power 2. For example, represent graphically if f of x equals x power 2 minus 2x minus 3, then determine the sign of the function. The solution. X power 2 minus 2x minus 3 equals 0. So x minus 3 and x plus 1 equals 0. We factorize the equation. We put instead of f of x, we put instead of it 0. And we try to solve the equation to find the value of x. Then the two roots are negative 1 and 3. So the curve intersects the x-axis at negative 1 and what? And 3. So the representation will be negative 1 and 0, 3 and 0, and we will find the curve of the function by using the rules we studied before in the first lesson. So, and we will be able to represent the curve. Then from the graph we get what? F of x greater than 0 when x belongs to R difference negative 1 closed 3 closed again. Greater than 0. Where is the part which is greater than 0? Here is the part which is greater than 0. And that's also the part greater than 0. So, and this one is extended and this one is extended. So, all the numbers from 3 and more to infinity is positive, and negative 1 and less to negative infinity is positive. So the answer is R difference without what? Without the space from negative 1 to 3. So x belongs to R difference negative 1 closed, 3 closed. Okay. Now, f of x is smaller than 0. Smaller than 0, where is that part which is smaller than 0? Here is this part. That's the part which is smaller than 0. Smaller than 0 means up below the x-axis. That's the negative part. The negative part is from what? From negative 1 to 3. Opened. And equals 0 at the solution set, which is negative 1 and 3. Second, if the discriminant is smaller than 0. Smaller than 0 means negative if the discriminant is negative. Then there are no real roots. There are no real roots. For example, there is no any intersection with the x-axis. If the curve is opened upward or the curve is opened downward, there is no intersection. If a greater than 0, which is the coefficient of x power 2, a is the coefficient of x power 2. If a greater than 0, then the function greater than 0. If a smaller than 0, then the function is also smaller than 0. And here is the representation of the sign of the function. There is no representation because there is no intersection with the x-axis. Then the sign is as the coefficient of x power 2. So all the line will have the sign of the coefficient of x power 2. If the x power 2 is positive, then the sign will be positive. If the sign of x power 2 is negative, so it will be negative, the sign of the coefficient. Okay. Let's have an example. Represent graphically f, where f of x equals x power 2 minus 4x plus 5. Then determine the sign of the function. The solution. First, we represented the equation. As we studied before in the first lesson. And we find the discriminant b power 2 minus 4ac. And by substituting, we get that the discriminant is negative 4, which is smaller than 0. That means that the sign of the function, this is the equation, the equation x power 2 minus 4x plus 5 equals 0, has no real roots. There is no intersection with the x-axis as we see in the representation. So the sign of the function is positive. Why is it positive? Because the sign of the coefficient of x power 2 is positive, so the function is also positive. If this sign is negative, so the answer is negative. Third, b power 2 minus 4ac equals 0. Then there are two equal roots. Again, b power 2 minus 4ac equals 0. Then there are two equal roots. For example, that's the representation. We represent, for example, if this the representation, the intersection with the x-axis is at one point. If it is opened upward or downward, we have only one point. So if a greater than 0, f of x greater than 0, f of x for all the numbers greater than L and smaller than L, and will be equal 0 at L. The same in this part. A smaller than 0. If A smaller than 0, then all the values will be negative after and before L, but at L it will be 0. So the representation for this rule will be, as you see, negative infinity and infinity, and we represent only one answer. There is only one answer, which is what? Which is M. Before M, the coefficient of x power 2. After M also, the coefficient of x power 2. It will be before M, it will be as x power 2. After M, it will be as x power 2. At M, it will be equals what? Equals 0. For example, represent graphically f, where f of x equals 4x power 2 minus 4x plus 1. Then determine the sign of the function f. The solution. We represented it by the lesson we studied in the first term. We studied it the lesson 1. I mean the lesson 1 in the first term. Then we try to find the discriminant. And we find the discriminant b power 2 minus 4ac. The answer is 0. So the equation has two equal roots. So the equation has what? Two equal roots. Why? Because the discriminant equals what? Equals 0. Then we will try to find the value of x. We will try to find the value of x. So after solving this equation by putting f of x 0, we will solve this equation to find that x equals 1 over 2. After solving the equation and determining the value of x, so f of x equals 0 at x equals half, okay? And f of x greater than 0, then when x not equals what? Not equals half. All the line is positive. Why the line is positive? Because the coefficient of x power 2 is positive. The coefficient of x power 2 is positive, so f of x greater than 0. If the coefficient of x power 2 is negative, so the coefficient f of x will be smaller than 0. Exercise. Determine the sign of the following functions. Determine the sign of the following functions. First, f of x equals 2x minus 3. F of x equals 2x minus 3. So we'll try to find the value of x. First, we will try to find the value of x. So 2x minus 3 equals 0. By adding 3 to both sides, 2x equals 3. Then dividing 2 to both sides, x will be equal 3 over 2. So the value is 3 over 2. So here is the representation. X and the sign of f of x. We have only one answer. So here is 0 and its value is 3 over 2. The sign of function is what? The sign of x is what? The coefficient of x is positive or negative? It's positive. So before will be opposite and after will be as. Again, before will be opposite and after will be as. This function is what? This function is a linear function. So before is what? Is opposite. That's negative infinity and infinity. So it will be opposite to the sign of x, which is the negative. That's all the negative part. And after 3 over 2 will be what? Will be positive. So f of x is positive at x belongs to what? Is positive at x belongs to negative 3 over 2, 3 over 2 opened to infinity opened. 3 over 2 opened to infinity opened. And f of x is negative at x belongs to from negative infinity to 3 over 2. From negative infinity opened to 3 over 2 opened. And f of x is equals 0 at x belongs to what? Belongs to 3 over 2. Okay? Now, another example. F of x equals 1 plus x power 2. 1 plus x power 2. It's a quadratic equation. So we will find the discriminant b power 2 minus 4ac. b is the coefficient of x. We have no x, it will be 0. Minus 4 times a is the coefficient of x power 2, which is 1. Times c, which is the absolute term, which is 1. So the answer is what? The answer is 4, which is smaller than 0. So the discriminant is smaller than 0. So its representation is, here is x and here is the sign of the function. There is no representation, negative infinity, infinity. So the function takes the sign of what? The sign of x power 2. X power 2 is positive. So the function is what? Is also positive. So f of x is positive at x belongs to what? Belongs to all the number line. So belongs to R. F of x is negative at f of x is negative at, is there is any negative part? No. So x belongs to what? To phi. F of x is 0 at x belongs to what? X belongs to also phi. Another example. F of x equals x power 2 plus 4 minus 4, x power 2 minus 4. It's a quadratic equation. We will find the discriminant. B power 2 minus 4ac. B is 0. So 0 minus 4 times a equals 1 and c equals negative 4. So the answer is 16. 16 is greater than 0. So there are two different real roots. We will try to find the value of this equation. We put f of x 0. So by solving the equation, it will be x power 2 equals 4. Then x will be equal positive or negative 2. So there are two solutions, which is 2 and negative 2. The representation is negative infinity, infinity, x, f of x. If y is 0, x is negative 2. If y 0, x is 2. Between the two roots, the sign is opposite to the coefficient of x power 2. X power 2 is what? Its sign is, it's a coefficient. The sign of its coefficient is positive. So we put the opposite between the two roots. And after 2, it will be the same. And after, before negative 2, it will be the same. Then f of x is positive at x belongs to what? We can write it as negative infinity, from negative infinity to negative 2, opened, union from 2 to infinity, opened. Or we can write it as r difference this part, r difference this part, which is from negative 2 closed to 2 closed. That's the first one. Then f of x is negative at x belongs to, from negative 2 opened to 2 opened. The last one, f of x is 0 at what? At x belongs to negative 2 and 2. Another example, it's a quadratic equation, so we will find the discriminant. B power 2 minus 4ac equals b, which is 4, 4 power 2 minus 4 times 1, because the coefficient of x power 2 is 1, times c, which is 4. So the answer is what? Is 0. So we have only one real root. X power 2 plus 4x plus 4 equals 0. By factorizing the equation, we will find that x equals what? X equals 2. Represent the function. By representing the function negative infinity, infinity, it will be, here is x and f of x. So if f of x is 0, x was 2, and this will take all as the sign of x power 2. X power 2 is positive, so all the function is positive except 2. All the function is positive except 2. So f of x is positive at, f of x is positive at what? At r difference 2. At r difference 2. F of x is negative at what? x belongs to what? Belongs to phi. Where is x belongs to? And f of x is 0 at x belongs to